Welcome back, everybody, to lesson 5.2. Today is just a quick review of radicals. It's something that I thought that we should go back over after the quadratics unit. So remember, radicals are like square roots, cube roots, like that. So it's this little symbol. If it has the 3 out front, that means I'm taking the cube root of something. And inside the radical, so this is like cube root of 12. This thing inside the radical is called the radicand. It's the thing that's being rooted. Also remember, and we're going to review this a little later on, I can write radicals roots as exponents. So like the cube root of 12, I can rewrite as 12 to the 1/3 power. So we're going to use that fact a little bit later on. We're simplifying some stuff, but let's get cooking, reviewing radicals. So the first thing I want to talk about with radicals is remember these couple rules right here. Basically, all these are saying is if I'm taking the root of numerator and denominator, I'm taking the same root of both. I can rewrite it as the root of the entire fraction. So for example, down here, square root of 10 over square root of 2, because both of these are square roots, we can do 10 divided by 2, which is just 5, and this is just the square root of 5. Product rule is similar with multiplication. If I'm taking the same root of two things that are being multiplied, then I can multiply the radicands. So I can do x times y and just take the 8th root, or the whatever root this is, of x times y. So in our example down here, we see we're taking the square root of both 10 and x. Since it's the same root of both of them, I can just multiply the radicands and I can get the square root of 10x. All right, so this problem I wanted to show you. I want you to take a look at this. We're going to do this in class, but basically what I want you to do with this problem is I want you to answer it without a calculator, and I want you to give me the exact answer of this width in yards. So be careful, pay attention to the units. Remember, we just started a section on dimensional analysis. Pay attention to the units to make sure that you give me an answer that is an exact answer. So not a decimal approximation. Give me the exact answer for this problem. So we're also going to take a look back at simplifying radicals. And this may come into play in that previous problem. I don't know. You're going to have to do it and find out if it comes into play. So simplifying radicals, there's a portion of your EOC that is non-calculator. There's actually nothing on your EOC that is required for you to use a calculator. Everything can be done without a calculator, but it might make some things faster. But things like simplifying radicals, if you get pretty quick at this, then it's going to help you write out exact answers to stuff instead of decimal approximations. So if I simplify this, remember basically what I'm going to do is I'm going to look for the greatest perfect square that this radicand is divisible by. So to do that, I'm going to start listing out perfect squares, like 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. And then I'm going to keep going. Basically, I'm going to keep going until I get something that's bigger than this, because if I get something that's bigger than 98, then 98 cannot be divisible by that. So I'm going to keep going until I get there. So I've got 8 squared is 64, 9 squared is 81, and then 10 squared is 100. All right, so this is where I stop because now I've gotten something that's larger than this. So I want to go through each one of these and figure out if 98 is divisible by them. So 98 is clearly not divisible by 100. 98 is not divisible by 81. It's not divisible by 64, but I notice it is divisible by 49. Specifically, 98 divided by 49 is going to give me 2. So what I'm going to do basically, once I've identified whichever is the largest perfect square that's divisible by, is I can rewrite this as a square root of 49 times the square root of 2. Now this is helpful because I actually know the square root of 49. Square root of 49 is 7. So I can rewrite this as 7 square root of 2. So this would be the simplified version of this radical. All right, so again, find the greatest perfect square the radicand is divisible by, factor out that perfect square and rewrite your radical as the product of 2 radicals, and then simplify. If you've done this correctly, you should be left with a simplified version of your radical. All right, so then the last thing that we're going to do is we're just going to try and simplify expressions. So, and recall up here, so I'm giving you this hint that we can write a square root as an exponent of 1/2. So I'm going to leave the second one up to you, but the first one, I'm going to take a look at this and I'm going to say, all right, I can rewrite this as the square root of 300 times the square root of x to the 12th. Now, if we remember, I can rewrite this square root as an exponent of 1/2, and then over here, I notice that this is divisible by 100. So I can rewrite this as the square root of 100 times the square root of 3. It's important this is divisible by 100 because 100 is a perfect square. And then over here, I could rewrite this term as x to the 12th to the 1/2, and now I can invoke my exponent rules, and I can multiply 1/2 by 12. And so what I end up with is I notice this term So this square root of 300, we'll simplify it to 10 square root of 3. And then this x term, we'll simplify it to x to the 6th. So then this would be the simplified version of this expression. So I'm going to leave the second one up to you. We will go through these in class, but I'm going to leave that second example up to you. So that is it for today. Today we talked about just radicals, simplifying radicals. And then we also spoke briefly about expressing radicals using exponents in that last part. So if you have any questions, make sure you bring them to class. I hope you took some good notes, and I hope you have a fantastic day. I'll see you in the next video.